Hey students, so welcome to the next set of videos that we're going to be working through, and these are ones that are going to be connected to Unit 6 and what the concepts that we're going to be looking at least this video and the next one, are going to be focusing on how we deal with design. Because it's one thing to be able to make something that solves a problem, it's another to have something that people will actually want, that they're willing to pay for, that they'll enjoy. And this is where we're going to get into concepts of elements and principles of design. And in an art class or in a design class, this is a topic that they would be working on for weeks. There's a lot of detail and nuances that can go into this. But we're going to look at the basic concept and how it relates to engineering. And to help get us started, I'm going to go ahead and borrow a quote from Ove Arup. He was a structural engineer, and we're going to talk about some of his more famous projects, like the Sydney Opera House. But this quote really affects kind of what we're looking at in this unit. See, engineering is not a science. Science studies particular events to find general laws. Engineering design makes use of the laws to solve particular practical problems, and in this it is very closely related to arts or crafts. And I think that's a very true statement, because it's one thing to create a product that works, it's another thing to create one that people will want. And as we look through this, I do want you to recognize that there is a major component to art in this, and I do encourage you to go back and look at the element of design and the principles of design video from a graphic designer, so you can see some of the difference in these, but also to go ahead and reinforce the concepts that we're looking at. So in this video, we're going to go ahead and look at the visual design elements, okay? And we're going to talk about some of the details and how it kind of connects to engineering and science a bit more than it may with art, at least in this video. So vocabulary that you should know is the 8 integral components that go into good design, okay? We're going to talk about points, lines, color, value, shape, form, space, and texture, okay? And we'll have some good examples of kind of how you see those, okay? So one that often gets relegated kind of out of the art side of things but remains with science and engineering side is points, okay? And we know mathematically these are the most basic identification of an object. It's a location more than anything. But without dimension, without coordinates, but being able to recognize where it is, that's actually used a lot in computer animated features, okay? You'll create a skeleton, and each joint, elbow, joint of a finger, you know, all of those go ahead and have to be identified a location, so the rest of the form and shape can go ahead and be moved around in the simulations in the software, okay? So while it's not something that you're going to see a lot in the artistic side, knowing about points is a good idea for virtual modeling. So for lines, we may think about it as kind of the mathematical definition, where a line is basically a continuous set of points, okay, where they are just so close together that they just create a continuous line. And these only have really length as a dimension, okay? And visually we may consider some depth, and they start to become more in terms of shapes. But the idea of these lines is they can be used in different ways, okay? We can use them to define a boundary. So when we're seeing the line creating the triangle, we can use it to identify, indicate the volume of an object, okay? How we're actually using the lines to go ahead and make it perceived to have a star in there, we're able to go ahead and help define that volume. We can use it for perspective and depth, okay? Things like what we're seeing with the road, and a long line because we're close, but a shorter but equivalent line physically as it gets closer to the horizon. We can use it to go ahead and help with texture and patterns, okay? Some of the things that we're seeing with the piano keys. And we can also use it to apply emotion, okay? In terms of lines, we need to recognize that we're going to have different types: vertical, horizontal, diagonal, and curved, and each one of those is going to have a slightly different meaning. So in vertical lines, we can think about how they are characteristically, their dignity, their formalities, their stability. We see things like skyscrapers, and we know that they are strong. They've been standing there despite the elements. Stability, we see those vertical lines in historic buildings like the Brandenburg Gate. Other cases of where we see strength, again, skyscrapers, how the towering over us. Okay, there's something that can be a little intimidating about that. It's not something that we ignore. Now, horizontal lines generally are going to be calmer, peaceful, more relaxing. Frank Lloyd Wright used a lot of horizontal lines in his pieces. Now, that's not fully getting rid of vertical lines, but in general, he's trying to get the smoother, calmer feel to it. We see that a lot in more formal office buildings, something to take the stress off of it. Hospitals tend to be more horizontal to help imply some of the calm and relaxing nature for better health. Diagonal lines, though, usually is implying motion. Think about like a lightning bolt for the Flash, or what we're seeing in some of these structures. The Aztecs were very active. We saw them as almost warlike. And in the pyramids, there's movement that's implied. Imagine climbing all those stairs. Or we can see it as something in terms of how we set up maybe a loft. That's not necessarily what you would see for a retirement home or for a more traditional office space. Okay? Now, curved lines, okay, are deeper concept in terms of freedom, smoothness. It's less formal, it's less organized, it's a bit more natural. So when we see the arcs of the roof, or where we see the curved edges, there are no sharp points, so the toy dog is going to be more friendly, more designed for kids. Or we see things like the Sydney Opera House that I mentioned earlier, the curved shapes, much more natural. And as a entertainment venue, you go there relaxed. You're not expecting something violent or highly active, okay? But it's still open to a lot of interpretation. So the next concept is talking about color. And there are different ways that we can actually define color, okay? Now, probably the one that you're most familiar with is identifying hue, which is what is the base color. Your red, green, blue, oranges, blue, purples, and violets. Value, though, is a related concept to that, and you're defining how light or dark it may be. Okay, so while we may consider that to be black versus white, imagine having a red. Is it a dark red, or is it a brighter fire truck red, or is it something a bit more pastel, okay, that you may see in the spring? Okay, and that's the value of how light or dark that base color may be. And then saturation is how pure it is in relative to gray. So there's a concept in design of a neutral gray color. Think about like neutrally gray clouds. It's not really down or dark, but at the same point it's not bright or lively. Okay? Whereas once you start getting back to that intensity, that purity of the color, you start looking at it other ways. Now, another concept with color is identifying what's considered the temperature. Some colors are cool, calming, relaxed, more subtle, and these are your blues, purples, greens, things that get closer to looking black. And then you have warmer, more energy active colors, reds, oranges, yellows. And again, it depends on values and the saturation and brightness. But another important thing to kind of recognize with color is that it has effects on your design. Okay? So in this case, we're seeing the color green, and for us, at least in the United States, green is kind of a color associated with new life. It can be associated with green, environmentally friendly solutions. We see, imagine an extension cord plugged into the SUV here, and we're kind of recognizing, oh, that's not burning oil. It's good for the environment, and green reinforces that concept. But we also want to recognize that green in other cultures can have different meaning. Even in the United States, we hear green with envy, okay? Or we may consider it with money and power. Okay? So there's a lot of variations that can go on with these different colors. And in other countries, green can almost be a taboo color, something that they don't want to see, that they almost have banned. Okay? So recognize that just because a color means one thing to us does not mean that that color is going to mean the same thing to everyone. Okay? Now, going back to value and how light or dark it may be, this is where we think about, is there a lot of light and brightness on it, or is it in a darker, more saturated, kind of paler room? Okay? And we actually go back to one of our past concepts of shading to go ahead and identify this. So the light colors, we don't necessarily include any details. We're not really connecting anything specific to those. But as we have that shading, we start saying, oh, there's a shelf, the top console portion. Whereas underneath, we know that it's going to be shaded. It's going to be darker. There's no light down there, and there's no real reason to be there. So using the concept of shading is one way that we can show value, and how we can use those together to make a two-dimensional sketch look three-dimensional. Which gets us into the concept of shape. Okay? So traditionally, we know that shape is going to be a two-dimensional area and is going to be enclosed by lines or curves. Okay? The types of shape will vary. Okay? Now we start off at the elementary level with geometric shapes, the squares, the circles, the triangles, the same tools that we've learned to use as the foundation of our sketches in CAD software or in the pencil and paper sketches that we've done. But as we add more to it, as we repeat the shapes, as we rotate them around, or we have them traveling in a consistent pattern, okay, that's where we get into mechanical concepts. Okay? So they take those simple shapes and they start getting some complexity out of them. Okay? Now, the most complex shapes generally are going to be the organic ones. These are things that can be created in nature, or they can be attempts at simulating nature. We may have an actual leaf from a tree, but when we go into the design process, we may use more curved lines, more defined edges to go ahead and emulate the pattern of a leaf. So in this case, we're dealing with more mechanical shapes, although there are components of it that start to look a little organic with the curves. But the mechanical portions, we see the repeating dots, we see repeating circles and lines, but organically, kind of the curves go ahead and take off some of the more mechanical elements of this. Okay. So going from shape into form is where we start looking at the three-dimensional volume, the solid nature of it. Okay. Now again, we're implying it two-dimensionally using shading, the value to go ahead and define that. But we can see those basic two-dimensional triangles being pieced together to create hexagonal patterns and getting into dodecahedrons. We have others where the circles are and curved lines start giving a bit more of a sponge pattern. Okay. As we get more mechanical, okay, notice the shapes are getting a little bit more complex, or we start increasing the size as we rotate outwards for the spiral, or we may use lines in combination with circles to go ahead and stretch out the patterns. And of course with values, and we see the shading, we're getting a better understanding that, oh, this is three-dimensional. It's not just two-dimensional that some of these may appear to be. Now, form is a big concept when you actually start getting into the design process. Okay, so in this case, we have the Oriental Pearl Tower in Shanghai. It's actually a transmission tower, but it's repeating a lot of different things for kind of the mechanical side. So we have the triangles kind of repeating around the circles, the spheres. We have multiple spheres that are going upwards. We have different observation decks. We have contrast with the tower behind it, where we have a kind of a chamfer triangular cut, where it switches into a cylindrical pattern. Okay, so the forms can define the shape that it actually takes and how it actually appears. Similar concept with the pyramids. You know, even though we may see them as triangular, you know, at least on the foremost one, we can see how it expands and the repeating patterns exist. Now the concept of form follows kind of a saying. There's form follows function. So one of the things that I want you thinking about in terms of the design process, especially for those that are going to continue through the engineering program here and get into things like engineering design and development course, it's one thing to solve a problem. It's another to make it more fluent, that people don't need to have it explained. So in this case, we can be looking at recycling bins. Okay? Now, we could consider the basic recycling bin as the starting point, where we just put in all of the products, things that we can recycle. But as we start putting color, changing the hue on these, okay, these all have a same general shape and functionality. But we can start using color to say, oh, these should be plastics, containers like metal cans. We can have one for paper. We can have another one for all of the organic material. Okay. But when form follows function, okay, this is where flat material like cardboard or paper can fit into the slot. Containers, whether it's a 20-ounce plastic bottle or if it's a 12-ounce aluminum can, we can associate that with the round hole. Okay. For the food waste, we can imagine, oh, it's going to smell some, so having it as a closed lid, but knowing that it'll be composted into dirt for trees, okay, can be recognized. And then we can have pretty much anything else go into a more universal container. Okay. So going back into the concept of those going into things like the engineering design and development course, okay, and how it makes sense to think about design when you're building something, is a quote from Helmut John, another architect and designer, and he's certainly won some awards for his work. But he says that a good engineer thinks in reverse and asks himself about the stylistic consequences of the components and systems he produces. So again, it's not just knowing that you have a working system. Okay? Is it going to be easier for people to go ahead and recognize and use as intended? Or is it going to be something that is possibly going to be done incorrectly? You know, imagine if you're colorblind, would you recognize these, the bins on the left, the same way that you would if you see in the defined slots with the bins on the right? Okay. So even though this may require more material and may include other complexities to it, it's a conscious decision to come up with a better solution. Now, another concept that we're going to look over is space. Okay? And we're not talking about outer space. We're talking about where you have an interaction between an object and its environment. Okay? So the area between and around parts of an image or in real life have some implied changes to that object. Okay? So there are two types that we need to be caring about. Okay? positive space, which is the object itself, and the negative space, okay? Everything else around it. So when you look at this, okay, we see tables, we see people in there. What is it that catches your attention first? Is it the tables? Or do you look a little deeper and you see a grid-like pattern? Okay. Now, I don't think that's the best example, so let's look at some other places, especially where we see negative space. Okay. So one is we can look at common logos. Okay. With FedEx, okay, most of you have probably seen their vans around the area. Okay. But how many of you have actually paid attention to the arrow inside the ENX? Now FedEx, we know, is supposed to be able to take an object and move it to its destination. It's traveling in a forward direction. So them slipping in that little arrow as a negative space is pretty clever. Now in the image below it, what do you see? Some may see it as a vase. Okay? The white, could be for holding a candle or holding an object on a table. But some of you, or if you look for everything else, you may notice that there are two people having a conversation, looking at each other. Now, negative space does not necessarily need to be in the exact same orientation. Okay? So in the third set, we have a superhero versus a villain. Okay? Now, in this orientation, we may notice Batman fairly easily. His crawl, his nose, rough chin. Okay? But you may notice that that's upside down. When we put it right side up, okay, and maybe we still see Batman hanging upside down, you might recognize the Penguin. A longer nose, a flatter face. Okay? These are cases of negative space being used in combination with the rotation. Now, in real life, that space can be evident in the images in the depth. Okay? We see a busy space in terms of buildings, but the canal is pretty clear. There's not a lot going on in there. Okay? Here, on the inside, we see a smooth, kind of clean room. But outside of that circle, we see the rest of the wilderness. Okay? Active trees, limbs, plants growing. Okay? So whether it's two-dimensional design or if it's three-dimensional layouts, think about how the space is used to more effectively manage how the objects are working. Okay. Now we're going to get into the last of the concepts with texture. Okay. So the idea of texture is it smooth? Is it rough? What's the physical profile like? Okay. Now smooth, at least when we're rendering them two-dimensionally, are going to be more reflective. We're going to see more intense color, okay, the hue and how it pops out. There's less shadows that are going to be formed in there. Okay? So we see a lot of smoothness on these, the top right and top center. We see some smoothness in the bottom right. Okay? But roughness is where it starts absorbing light and we start getting more shadows attached to it. And they're going to appear darker. Okay? So in particular, the top left, okay, the bottom center, okay, there's a lot more shade and value shown in those than we are seeing with light. Now, in real life, okay, a metal facade on Disney's Concert Hall in Los Angeles uses kind of sheet metal for its facade. So we know that it's going to be reflective, it's going to be well lit. We know that it's going to appear smooth. We're not seeing any rough edges to it. Whereas if we look at the Park Güell in Barcelona, we're seeing the bricks, the rocks that have been formed and have gone through hundreds of years of weathering. So even though we see a lot of light, we're seeing a lot of lighter colors. Okay? We're seeing a lot of the shadows that are implying that it's a rougher surface. Now keep in mind, rough does not necessarily mean that it's coarse or hard. Okay? We can have fluff, okay? Feathers on a bird, where we know that there's a lot of rough elements to it. We're seeing a lot of the same shadows, and we're seeing it's a little darker than maybe what we expected. But it's still enough to go ahead and understand that rough in terms of texture does not necessarily mean rough as in physically hardness. So again, a lot of concepts that go into this, and while the elements of design are going to be critical, how we actually start using them gets us into the principles of design in the next video. So once again, kind of think about how these artistic concepts can affect the way that you work as a designer or how it works as an engineer.